Find the volume and surface area of the following prism. So we have this shape here, and we have a rectangle at the front and an isosceles triangle on top. I know it's isosceles because these two lines mean equal length, and an isosceles triangle is a triangle with two lines of equal length, two sides of equal length, and two angles of equal length. So the base of our shape is 8 meters, the height is 7 meters, the height of the rectangular part, and the height of the overall structure is 10 meters. And the length of it is 9 meters. So this is a prism, which means that the face at the front, so the rectangle with the triangle on top, is the same cross section the entire way through the shape. So if I was to slice this shape in half, or anywhere along the length of the shape, I would have the same cross section, the same face. So volume. We work out the area of the cross section, which is the front face of the shape. So we need to work out the area of the front of the shape. So let's start with the rectangle. So here's our rectangle, and it's 8 by 7. So I'm labeling this as A. So A, the rectangle, the area of this is going to be the length multiplied by the width. So 8 multiplied by 7 is 56 meters squared. So the area of this rectangle is 56 meters squared. Then B is going to be the triangle on top, the isosceles triangle on top. The formula for the area of a triangle is half times base times height. So the area of a triangle is half times base times height. So the base of this triangle is going to be 8 because the base of the rectangle is 8. So this part here is going to be labelled as 8. And if the overall height of the structure is 10 and the height of the rectangle is 7, then 10 minus 7 leaves us with 3 for the height. So the perpendicular height of our triangle is 3 and the base is 8. So it's going to be half times base times height. So half times 8 times 3. 8 times 3 is 24, and half of 24 is 12 meters squared. So the area of the triangle at the top is 12 meters squared. So the area of the entire cross section, or the front face, is going to be the area of A plus the area of B. So it's going to be 56 plus 12. So A plus B will be 68 meters squared. So the area of the cross section at the front, the face of our shape, is going to be 68 meters squared. And to get the volume of a prism, it's going to be the area of the cross section, which is the area of the front, multiplied by the length. So the area of the front, the area of the cross section, is 68, and the length is 9 meters. So 68 multiplied by 9 is 612 meters cubed. And you must have meters cubed for volume. So we've worked out the volume of the prism. Now we need to figure out the surface area of the prism. Okay, so now we're going to figure out the surface area of the prism. So again, this is our shape. We have a rectangle at the front, and we're going to have a rectangle at the back as well that we can't see. We also have a triangle at the front and another triangle at the back that we can't see. We have a rectangle at the side and another rectangle at the other side that we can't see. A rectangle on the roof and another rectangle on the other side of the roof that we cannot see. And then we also have a rectangle along the bottom that we can't see either. So we need to find the area of each of these shapes and add them all together. Okay, so surface area. What we want to do is draw the net for the two shapes. So some faces are not included when calculating the surface area of the prism, as they are hidden. We shade these areas in red. So basically, if we were to break this shape into two pieces, so the top part is just a triangular prism. It's like a Toblerone box. And the bottom shape is a cuboid or rectangular prism. It's two shapes on top of each other, two three-dimensional shapes on top of each other. But the place at which they're connected is not going to be part of the surface area. So for example, if we were just to take the net of the triangular prism at the top and break it down, we would have a triangle at the front, a triangle at the back that we can't see, a rectangle at one side, and another rectangle at the other side that we can't see. But we would also have a base to our triangular prism. But this is not going to be included because it's stuck on to the rectangular prism at the bottom. Likewise, if we were to take the rectangular prism at the bottom, we would have the front, which is a rectangle. We'd have the side, which is a rectangle. We'd have a top as well, which is shaded in red. But again, that's not going to be included because it's stuck on to our triangular prism at the top. And if we were to draw the net of our cuboid or a rectangular prism, again, we'd have the front and the back that we can't see. We'd have the side and the other side that we can't see. And we'd have the base of it or the bottom of it, which we can't see either, which would be along here. And then the top, which is in red, that we're not going to include. So just being careful that you don't include parts that you don't need. Okay, so let's get back to our triangular prism at the top. So as I said, we have an isosceles triangle, and I know it's isosceles because I have these two little lines, which tells me that these lengths are equal. And if I cut a isosceles triangle in half, so drop a perpendicular down the center, I cut it into two equal right angle triangles. So what I'm going to do is use Pythagoras' theorem to figure out what this slant length is going to be. And it's been labelled as h, the hypotenuse. So if I just zoom in on this, so here's our isosceles triangle that we have at the front. I've dropped a perpendicular down the centre to cut it into two equal right angle triangles. So there's my right angle, and on the other side it would be here. I know that the height is 3 meters, and I know that the base of the entire triangle is 8 meters. So the base of the right angle triangle will be 4 meters. So this length here is 4 meters, and on the other side it's also 4 meters. So I'm just going to focus in on this right angle triangle here and try and figure out what this slant height is. So it's actually the hypotenuse of our smaller triangle, the hypotenuse being the longest side. So we're going to use Pythagoras' theorem, which is c squared equals a squared plus b squared. And this is given to us in the formula tables. So Pythagoras' theorem is used to find the side of a right-angled triangle. It can only be used with right-angled triangles. So the c always stands for the longest side, which is the hypotenuse, and it's labelled as h. And it's always across from the right angle. So this is our longest side. We've labelled it as h, so it's just going to be h squared. Then the a and the b are the other sides, and it doesn't matter which way you label these because you'll still get the same answer. So I'm going to label the 4 as a. So I'm going to have a squared, which is 4 squared. And I'm going to label the 3 as b. So I'm going to have plus b squared, which is plus 3 squared. And as I said, if we had 3 squared plus 4 squared, if we had it the other way around, it won't make any difference. So long as the longest side is the one that is on the left of the equal sign. So the longest side must always be the c. So 4 squared is 16, 3 squared is 9, and 16 plus 9 is 25. So if h squared equals 25, then h will equal the square root of 25, and the square root of 25 is 5, so h will equal 5 meters. So this length here is going to be 5 meters. So if I go back to my original shape, I now know that this length here is 5, and this length here is also 5. So I'm going to label that on my diagram. I know that this length here is 9, so this is also 9. I know that this is 7, so this is also 7. I know that this is 8, so this is also 8. And if this is 9, then this is also 9. And if this is 7, then this is also 7. Okay, so I want to find the surface area of the triangular prism at the top. So I have a triangle at the front, which I already worked out in the last question to be 12 meters squared. So the triangle at the front is 12 meters squared, and the triangle at the back that we cannot see is also 12 meters squared. And I got the 12 because I said half times base times height. The base is 8, the height is 3, because this is 10 and this is 7, so that leaves 3. So half times 8 times 3 gives me 12. So 8 times 3 is 24, and half of 24 is 12. So 12 meters squared is the triangle at the front, 12 meters squared is the triangle at the back. Now we need to figure out the area of the roof. So it's a rectangle, so it's going to be 5 multiplied by 9, which is going to be 45. And then the other side that we cannot see is also going to be 45. 9 by 5 is 45. So again, we're not interested in this red section, which is the base of the triangular prism, because it's stuck on to the top of the rectangular prism, so it's not counted as its surface area. So we have our 4 sections, and we just need to add them together. So we have 45 plus 12 plus 45 plus 12, and that gives us 114 meters squared. So that's the surface area of the triangular prism at the top, 114 meters squared. So now we need to figure out the surface area of the rectangular prism at the bottom. So again, here it is drawn out, and remember we're not interested in the red part because that is stuck onto the triangular prism at the top. So we have the front, which is going to be 8 by 7, because it's a rectangular. The length by the width is 8 by 7. And 8 by 7 or 7 by 8 is 56. So the front is 56, and the back is also 56 that we can't see. So the front is 56, and then the back that we cannot see is also 56. Then the side is going to be 7 by 9, and 7 by 9 is 63. So this side is 63, and then the other side that we can't see is also going to be 63. So we have the front and the back and the 2 sides, and now we need the base, the bottom of our rectangular prism, and that's going to be 8 multiplied by 9. And 8 multiplied by 9 or 9 multiplied by 8 is going to be 72. And again, we don't need the other red part, which would be the top, because again, it is stuck onto the triangular prism. So we just have to add up these areas, 63 plus 56 plus 63 plus 56 plus 72, and that gives us 310 meters squared. So this is the surface area of the rectangular prism at the bottom, without including the red part. So to get the total surface area of the entire prism, we just add 114 meters squared and 310 meters squared, and we get 424 meters squared.